Here's an example. We want to do the integral of x squared over x squared plus 5x plus 6. The first thing we notice is that this is degree 2 over degree 2, and so we have to do long division first, right? The degree of the top is not less than the degree of the bottom. So we have to do long division. We got to do x squared divided by x squared plus 5x plus 6. And it has to be long division. We can't do synthetic division here. Luckily, it's a pretty short long division. We ask ourselves, what do I got to multiply x by to get x? The answer is 1. I put a 1 up here. And then I do 1 times x squared plus 5x plus 6. I put it down here. I subtract. And my remainder would be negative 5x minus 6. Okay, that is the remainder because that's degree 1. The original denominator was degree 2. Okay, so let's see. That tells me that my original fraction here is actually equal to 1 plus the remainder over the original denominator. Okay. Now eventually we want to integrate this. I know I can integrate 1. Okay, the integral of 1 is going to be x. I got to focus on integrating this guy here. And we can do that by realizing that we can factor the bottom. The bottom's is going to factor as x plus 2 times x plus 3. And we can, by partial fractions, that's going to split up as something over x plus 2 plus something over x plus 3. The 1 is just coming along for the ride every time. And we can figure out what those numerators are by using the cover-up method. So let's see. To figure out what goes above the x plus 2, we're gonna cover up the x plus 2. We're going to plug in x equals negative 2. If I plug in x equals negative 2, on the top I'd have positive 10 minus 6, so that's 4. On the bottom I just have 1, so 4 over 1 is 4. To figure out what goes above the x plus 3, I cover up the x plus 3, I plug in x equals negative 3. I'd have positive 15 minus 6, which is 9. I'd have negative 3 plus 2, which is negative 1. So 9 over negative 1, negative 9. That's how the partial fraction decomposition would go. And now I've got my original fraction. So this is my original fraction. I've actually broke it up into 3 different pieces here, and all 3 of which are a very simple integral. So when I go to actually compute my integral up here, I'm just integrating each one of these 3 pieces, and each of these is very easy. The integral of 1 is going to be x. The integral of the next fraction there is just going to be 4 natural log of x plus 2. And the integral of the next fraction there is going to be minus 9 natural log of x plus 3. And then we tack on a plus c, and we're done. Okay. Technically, I should have been doing a u substitution for each of these. Right? For this one, u could have been x plus 2. For this one, u would have been x plus 3. But in each case, the du was just the same as dx. So each of these was like 1 over u, which is natural log u. So I didn't write it out.